Today we're working on solving and graphing linear inequalities. So to get us thinking about inequalities, let's do some review. So here I have 4 inequalities, and I wrote some directions about what we would like to do to them, so some operations per se. So on a piece of paper, let's have you work on these 4. So the first one says we want to multiply both sides by 4, and then write the appropriate inequality between the numbers. The second one, we're going to multiply both sides by 2 and write the appropriate inequality. Our third one, multiply both sides by -4 and write the appropriate inequality. And our fourth one, divide both sides by -3 and write the appropriate inequality. So take a minute and just do the operations with the multiplication and division, and we'll check those values. If we've done arithmetic correct, these should be the results, right? Multiplying both sides by 4, we end up with 24 and 8. So the question is, what inequality would be appropriate to use? Well, if we're comparing 24 and 8, 24 is greater than 8, so we have our greater than sign, just like 6 is greater than 2. So again, multiplying by 4, a positive number, just made the numbers 4 times larger. It did not change the inequality. So our second one, we had -4 is less than 7. We multiply both sides by 2. So we have -8 and 14. -8 is less than 14. So I just doubled the amount, but notice how it did not change the inequality sign. Our third one, we multiply both sides by -4. So we have -36, -12. Now thinking of the number line, -36 is to the left of -12. That means it is less than -12. Notice that's the opposite of what we started with. 9 was greater than 3. But by multiplying by the -4, look how it changed the inequality in our values. Now we had -12 is less than 6. We divided both sides by -3, and we have 4 and 2. Well, 4 is greater than 2. Well, look what that did. That also changed our inequality sign. Well, why is it happening? Well, for these two, we are multiplying and dividing by a negative value, right? Negative means you're taking the opposite of what you had before. So if you're taking the opposite of the values, you'd also have to take the opposite of the sign. So that's how it's impacting our rules here. So again, when you're working with the inequalities, remember, taking the opposite. When you multiply or divide by a negative number, that's going to impact your sign. So let's work on solving some inequalities, and then remember we're going to talk about graphing them. So here we have 6x minus 7 is greater than 2x plus 17. So just like we did before solving equations, we're going to follow the same steps to get the variable on one side and our constants on the other, and simplifying. So there's no fractions to deal with, no distribution over addition or subtraction. So we're going to start with the lowest variable, and our lowest variable here is 2x. So I would subtract 2x from each side of the inequality. So now I have 4x minus 7 is greater than 17. We're going to undo that subtraction by adding 7 to each side. So now 4x is greater than 24. We're then going to undo the multiplication by division. So we're going to divide each side by 4, and it says that x is greater than 6. So what does that mean? 6 is kind of our boundary, right? And x, being the variable, is saying any values more than 6 meets the requirements to my original inequality. So when we go to graph this, there's going to be an infinite set of values. It's a range of values that we're going to demonstrate. So we're going to have a number line, right? And we want to see 0. We're going to want to see some numbers to the right and left of it. And we definitely need to see what's happening at 6. So I just decided to go 6 units to the left, 6 units to the right in the number line to show the direction. And so since 6 is our boundary, right? We're going to have to put a point on a number line at 6. Now the question is, does 6 meet the requirements for inequality? Well, let's check. If I put 6 here, is 6 greater than 6? No, 6 is not greater than 6. So I can't use the value of 6 for part of my result. So I'm going to leave it as an open point on my number line. Now, where are all the numbers that are greater than 6? That's to the right of 6. So anything bigger than 6 would work. So I'm going to shade to the right of 6 on the number line. So here's a depiction of all the numbers that meet this rule, x is greater than 6. Here's our graphical representation for that. So we want to see the solution to the inequality and its graphical representation, which we've done so far. And I'm sure some of you have done this before. It's just a quick review, reminding that inequality has an infinite number of set of solutions for that rule. So let's try another one. So here's our inequality. 6 times the quantity 5x plus 2 minus 8 times the quantity 8x plus 7 is greater than or equal to 24. So again, following the rules that we did before, we have some distribution that we have to do across the addition. So I'm going to distribute 6 to 5x and 2, and the negative 8 to 8x and 7. So I would end up with 30x plus 12 minus 64x minus 56. Remember, negative times a positive is going to be a negative there. Same thing here, is greater than or equal to 24. Now we're going to do some simplifying, right? So look to the left of the inequality sign. Do you have any like terms you can combine together? We do. 30x and negative 64x, we can combine those. We also can combine our 12 and negative 56. So we've got negative 34x, combining your x's, combining your constants, negative 44 is greater than or equal to 24. We're going to undo this subtraction by addition, so we're going to add 44 to each side, which means negative 34x is greater than or equal to 68. To undo that multiplication, we're going to divide. We're going to divide by the negative 34. So a negative divided by a negative is going to be a positive. A positive divided by a negative is a negative. Remember, we're taking the opposite, taking the opposite, taking the opposite. So this sign is no longer going to be greater than or equal to, it's going to be less than or equal to. So x is less than or equal to negative 2. So that's our solution to the inequality. But what does it look like graphically? So again, we need a number line, and we definitely want to see what's happening at negative 2. So I'll do a number line again, with 0 showing 2 units to the right and left of my number line. Now negative 2 is our boundary, so I have to have a point here at negative 2. The question is, does that value satisfy the inequality or not? So let's substitute it in. Negative 2 is less than or equal to negative 2. It's equal to, it works. So because it works, we're going to fill that point in so it's solid. But where are all the other values that are less than or equal to negative 2? Those would be to the left of negative 2. So we're going to shade to the left. So our graphical representation for the solution set would be this. So let's try this one. 2 times the quantity, 7x minus 2, is greater than or equal to 14x plus 5. Okay, so we've got some distribution to do. 2 times 7x, 14x, 2 times negative 2, negative 4. Okay, is the left simplified? Yes. Is the right simplified? Yes. So what's your lowest variable? 14. So we're going to subtract 14x from each side. So this says negative 4 is greater than or equal to 5. Negative 4 cannot be greater than or equal to 5, so that's false. So just like we were solving equations, this has no solution. So if we were going to graphically represent it, we would just have a blank number line. Nothing can be shaded in because it's not true. Let's try this one. 3 times the quantity 4x minus 1 is less than 6 times the quantity 2x plus 5. So we got to distribute the 3 to the 4x and -1, and the 6, the 2x, and the 5. That means we have 12x minus 3 is less than 12x plus 30. Okay, the left is simplified, the right is simplified. So we're going to find the lowest variable. Our lowest variable is 12x. So I'm going to subtract 12x from each side of our inequality. That means -3 is less than 30. That's true. -3 is less than 30. So since it's a true statement, that means we have an infinitely many solutions. All of them are real solutions. So because there's infinitely many solutions, we'd have a number line. We could put 0 and some numbers to the left and right of it, like -100 and 100, and everything would be shaded because it's infinitely many solutions. So we've been given some inequalities to solve. Let's see if we can write some like we were doing before with equations. So here's a scenario. It says you can order movie tickets online for $7.50 each and a credit card processing fee of $2.50. You can spend no more than $40 on movie tickets. At most, how many tickets can you buy? So think about what we were doing before in our problem-solving process. What do we know? Underline that. What do we want to know? Circle that. Also think about what kind of variables do we have to work with for this scenario. Well, we know we can order movie tickets for $7.50, so I could underline that. And there's a flat credit card processing fee of $2.50. We know we can spend no more than $40 on movie tickets. So this is important here. We'd underline that part. What do we want to know? At most, how many tickets can you buy? So we would circle this. Now the part that stands out the most is the no more. How do we represent no more then? It wouldn't be equal because that means exactly how many can you buy. No more means you cannot exceed, right? If you can't go past it, that would have to be greater than or less than. Which one do you think it would be? If you can't go past, it would have to be less than or equal to the amount that you have to spend. So we know the sign. Talking about variables, what's the unknown here? Well, we don't know the number of tickets we can order, so that would be our variable. So let's say T is our number of tickets, that's our variable. And let's see, can we write an inequality? Well, we have to pay $2.50 for the credit card fee and $7.50 for every ticket that we buy. And we cannot spend more than $40 on these tickets. So we've got $2.50 plus $7.50 per ticket is less than or equal to the $40. Here's our inequality. Can you solve and see how many tickets we can buy? Sure we can. Using the same process we did before, undo the inequality. Subtract $2.50 from each side, divide by $7.50 on each side, and what will end up? Well, if we take $37.50 divided by $7.50, we have a 5. So we cannot buy more than 5 tickets with the $40 that we have. So our sentence will say at most you can order is 5 movie tickets. So today we were practicing solving and graphing inequalities that were given to us, and also writing and solving inequalities based on a scenario given to us. Now it's your turn to practice.